Hi, this is Christian from LBNL, and I want to show you a new feature that we've added to our therm7 program for showing the condensation potential on a cross-section. So this is surface condensation, not internal condensation. And I'll use an example here of a steel stud wall that I've drawn that you can see in a tutorial on our website, and it's a layer here, a plaster layer, insulation, a steel stud here, and some gypsum board on the inside. And if I click on the boundary condition on the inside here, you see it's selected by the red dot. There's one at the top and the bottom. And I press enter or double click on it. And if I go to the boundary condition library now, you see a new box down here for relative humidity. So this boundary condition always has meant this temperature is what the room air is here, and the air on this side, and the film coefficient next to this surface. The relative humidity now is the relative humidity of the air in this room, so it's kind of a bulk property. In this case it's set to 60%. I'll leave that, and we're going to calculate this file. It's a pretty simple one, so we have quick results. And now when we go to calculate display options, you see a new box here that's called Show Surface Condensation Potential. And again, this is only surface condensation. We can't model condensation inside of the model. And we call it potential because it's not guaranteed that at that relative humidity you'll get exactly their condensation, because there's always local effects going on in terms of air flows and maybe radiative effects from the room. But this is our best estimate of, based on this model, what happens. So if I turn this on, you see a little yellow line show up here and also here. And what that means is the program is predicting that in these areas there could be surface condensation. So the way we calculate that, if we go to a quick online dew point calculator, so our room temperature was 21.11 degrees, and we had set the relative humidity for 60%. So if we calculate here, that shows us that the dew point temperature is 13.05 degrees Celsius. If we go back to the model now, and we turn on this feature called View Temperature at Cursor, and we also change our results to, just to explain it to you, I'll show the mesh. And the reason this is important is Therm calculates temperatures at mesh points. It's not continuous, it's wherever there's a mesh point. So if you see here the temperature, if I hover over, you see this temperature dialog here, and you see it's right here at 17 degrees, and then as I move down, somewhere in the middle here, it jumps to 16.3. Really the temperature here is 16.3, and here's 17.0, and the program just in the middle kind of flips over. So we had the dew point temperature, we're looking for 13.05. So as we move along this surface, here it's 13.5, and then here the temperature dropped to 10.8. So the program is drawing in the midpoint here, even though it's 13.5 to 10.8. Somewhere in here the temperature drops below the dew point, and then along here it's 10.8, 10.2, 11.7, and then here the temperature is getting above that 13.05. So the program is highlighting the area of the cross-section that is under this 13.05 degrees Celsius, and that can be under condensation. Another nice way to see this is if you, let me turn this off, if you go to display options and you turn on the color flux magnitude and also this show surface condensation potential, what you'll see is, and this will take a second because I'm very zoomed in and it gets a lot slower. Actually, I'm going to pause it for a second here. So you see it very nicely in this view, which is the color flux magnitude. And so you see a lot of the heat flux is going, of course, through the metal stud, which is the short circuit which breaks through the insulation. And you see that the area under condensation pretty much matches the effect of this stud. So you see it's right around where the center part of the stud touches the wall is where you're going to get the lowest temperatures. So that's a new feature to see the surface condensation potential in Therm, and again it's driven by the relative humidity that you specify in the boundary condition library. And so you want to make sure that that value is set right for your interior condition. So this combination of temperature and relative humidity is going to determine the amount of moisture in the air. That's going to determine the dew point, and that's how Therm draws a section. So thank you very much. This was a quick overview of the new features in Therm 7.